It's 11 o'clock in Santiago. It's 3 in the afternoon, I think, in London.
Yes, it is.
And so I suggest we start this webinar. Well, first of all, I would like to thank you, Paul, for your time and for the presentation that you're going to give today on the research data repository of University College in London. As I understand, this data repository was launched in 2019, in June 2019. So we are really looking forward to hearing from you how that is going and what your experience is at your institution on research data management. So first, a few more words about you, Paul. You are Paul Ayris. You are the Vice Provost of UCL Library Services. You're also University College Copyrights Officer. Paul was the president of LIBER from 2010 to 2014. He's the co-chair of LERU, the League of European Research Universities, Community of Chief Information Officers. Paul also chairs the OAI Organizing Committee for the CERN Workshops on Innovations in Scholarly Communication. He is the chair of JISC Collections Electronic Information Resources Working Group. And in 2013, Paul also became the chief executive of UCL Press. He's also the member of the Provost's leadership team in UCL. He has a PhD in ecclesiastical history and publishes on English Reformation studies. Thank you, Paul, and thank you to all the people who are attending today this webinar, the next webinar of our series of webinars. The floor is yours, Paul.
Well, so thank you very much, and thank you very much for the invitation to join the webinar. It's an enormous pleasure to be working with CEPAL in Santiago again once more. I've been asked to talk about UCL's experience in establishing our new research data repository. So what I'm going to talk about in the next 30 minutes is really to set the context and the ambition for this new development, and talk a little bit about the costs. So this is what I'm going to talk about in the next 30 minutes. Look at the European context for research data management, why we prioritise this in UCL as a development that we wanted to fund. I'm going to look a bit at the LEARN project, which is an initial research data management project funded by the EU, to use some of the learning from that to feed into, the learning from that did feed into the development of our repository here. And then I will talk a bit about the repository. And I'm going to just pick a few issues to explain how we tackled the issues as we set up the repository as a pan-UCL service. So looking at things like architecture, where it fits into the system, metadata, what we tell researchers to do in terms of describing their data, and then maybe look at a little bit at cost, because that's the first question that any university manager will ask when you're wanting to establish something new. How much is all this going to cost? Then I'll conclude the talk by looking a bit at how we've changed our promotion system in UCL to reward openness and people following open science as an incentive to change the way that they work. And then bring this to some kind of conclusion. So if you were to pick the 8 areas of open science that have been identified by the European Commission, you would be looking at these 8 topics here on the screen. And on my screen anyway, I hope on yours too, I've highlighted 2 of them, which are in orange. So fair data and EOSC, the European Open Science Cloud, the aggregation of research data across Europe through a portal, which we're calling in Europe the European Open Science Cloud. These are the 2 areas of European open science policy that research data management and our new research data repository fit into. So it's 2 of the 8 pillars of open science that we're trying to tackle as we've set up this European development here in UCL. And if you were to look in more detail at the open science landscape for research-intensive universities, you could use our roadmap. So LERU, the League of European Research Universities, where I, as Wout has explained, I chair the policy group on open access and for the Chief Information Officers. We have 23 universities in LERU who are members of the grouping, and you can see here on the map approximately where they're placed in the continent of Europe. And we produced last year a roadmap with 41 recommendations on how universities can embrace open science, not just research data management, but the whole area of open science in all those 8 pillars. All these 8 pillars here, the roadmap goes through the 8 pillars and explains what you need to do if you're a university starting from absolute scratch. And this roadmap, I should be honest, I chaired the writing committee for this roadmap. This roadmap has been very influential in Europe amongst universities in starting the activity for open science at university level. And the LERU rectors, our 23 rectors from those universities, have also issued a leadership statement about the move to open science. And I put it on the screen here because what they really emphasise is becoming increasingly obvious as we introduce changes in those 8 pillars of open science to bring about open science practice at university level, and that is the need for a culture shift. So LERU wants to underline, they say in their statement, the importance of a culture shift which is needed to implement open science at university level. Because it is such a change. Open science and open data and fair data represent such a change in the way researchers work that unless they change the way they think and universities change the way they operate, it isn't going to be possible to move to an open science environment. One of the building blocks for our work here in establishing the Research Data Repository was the original EU-funded LEARN project, which ECLAC was a partner in with us in UCL and a number of other European universities, and we produced a number of outputs which fed our understanding of what was needed to deliver open science at university level. And one of the pieces of work that appears in our toolkit of best practice is the results of a UCL survey on research data, which was completed in 2015. We got quite a good response rate. We circulated just over 600 surveys, and half of them, just over 300, were completed. So that's quite a good return for a European survey. So it showed some level of engagement. But the picture that it painted of research data management was not the one that was conducive to developing open science. So, for example, question 34, in your most recent project, where did you keep your data? And 45% of the respondents, so we had 433 responses to this question, and 45% of the responses said they used a personal computer for storing their data. And now that's not very open science, because the personal computer may not have been attached to the UCL network. There would have been no regime, there isn't necessarily any regime for backing up the data on the computer or curating it for the long term. So using a personal computer for long-term storage is really not a very good idea. And only 5% of those respondents said we use central UCL facilities for storing and keeping our data for the long term. And that's not a good set of answers for a university that wants to develop open science practices, which are all about sharing and reuse, because those results are the absolute opposite of sharing and reuse. And another question which made us realise that the Research Data Management Repository, the RDR Research Data Repository, was needed was this question, question 61, in the questionnaire. So this was in 2015, before the RDR was launched. And the question was, at what stage of the project did you think about data management? And if you look at the graph, the pie chart here on the screen, you'll see that half of the respondents said very early on, or straight away, or right at the start of the project. So this is the segment on the right-hand side of the screen. But the other half of the respondents didn't think about research data management until quite late in the project, or in some cases, not at all. The end of the project, ad hoc, too late, never, were 4%. These, again, are not responses that are suggestive of a culture in research activity that will support open science activity. So that was our starting point. And the drivers, the actual drivers for establishing the repository, the RDR, were these. We did have central services for storing data. As we saw from the questionnaire, only 5% of UCL academics were using them. But there was a storage service. It wasn't a curation service. It wasn't meant for long-term curation. But there was a storage service where you could store data if you wanted to, but not many people were using it. And we do have separate repositories. We did have separate repositories which were much more heavily used for high-performance computing outputs. They're masses of data, petabytes of data. What we needed was a repository that would enable us to curate and store for the long term non-sensitive data and non-personal data which could be made open for sharing and reuse. We didn't have anything in the UCL infrastructure that delivered that kind of curation service. And research funders are increasingly beginning to require things of universities when they pay for research project funding to undertake research and produce data. They want, there's not a mandate for open data yet from research funders, but there are very strong requirements for long-term curation services where their data can be made available for sharing where that is appropriate. So no open data in funder mandates yet, but we feel that's on the way. That's the next step, and we didn't want to be left behind without a service that could deliver a long-term curation service that would meet funder requirements, because so much of our research budget is something like £500 million a year coming in across the university, and most of that, a lot of that comes from research funders. So meeting research funder requirements was really important. So those led us, the learning from the Learn project and the drivers to change in an open science environment led us to establish the Research Data Repository. And here on the screen, I've tried to place the repository in the UCL landscape. So the repository is run by two divisions, and I've highlighted those with dotted lines on the diagram. So in the top right, there's the library, which is part of the research domain in UCL, reporting to the Vice Provost for Research. And we run the service on a day-to-day basis. The library is the interface between the service and the infrastructure. And then information services here, highlighted bottom right, is the technical department, academic computing, that actually runs the infrastructure. And then the other divisions and faculties around the diagram are all the users of the service. So all these faculties here, arts and humanities, social and historical sciences, laws, brain sciences, medical sciences, population health sciences. There are 11 schools and faculties that are producing data that need to go into the repository, and it's these two divisions, the library and information services, that are providing the service for them. And this is what it looks like if you were to look at a diagram of the research workflow in the UCL. You have the researcher here on the left-hand side, writing research data management plans, writing a dissemination plan for how they're going to publish and disseminate the results of their research here on the left-hand side. And then there are a number of routes that they can follow. So for publications here on the top right-hand side, you can choose a number of routes. You can choose gold open access, so you can pay an article processing charge and publish in a hybrid journal, or you could publish with UCL Press, our born open access university press, where we do a lot of open access publishing of monographs. Or you could put your output in a green open access repository. So UCL Discovery is the UCL open access repository for publications that the library runs. But those two solutions don't deal with data. And that's what RDR, the Research Data Repository, is designed to support. It's meant to sit alongside the publications repository, but deal with all the data that is being produced, which are the building blocks for the publications that are being produced, analysing and making conclusions from the data that they've created. So this is the RDR, and you can either choose to make your data open and free at point of use. That's the recommended position that we take in the repository. It is open by default, but it isn't mandated, because you can restrict access to the data if that's what you want to do, or if that's a condition of your funder. So although the default position is open, and it's open by default, as open as possible, it is possible within RDR, for various reasons, where you might have to restrict your data, to put an embargo on the data, if that's what you choose to do. So once you've set up the repository, you need to produce a service layer and a series of service definitions. And metadata, fair data, is really an important building block of open data, because if your metadata is not fair, you won't be able to deliver open data. So this is the position that we take on metadata for the repository. You can either follow a discipline-specific schema. So medicine will have its own schema, physics will have its schema, chemistry will have its schema. We don't impose a one-size-fits-all solution on the different disciplines. That wouldn't work. You can either use your discipline-specific schema, or if you haven't got a discipline-specific code, and history, I'm a historian, history doesn't have its own generally accepted schema, you would need to fill in these metadata fields here in the template. You need to give it a DOI, you need to name, for example, the name and affiliation of the main researchers who produce the data. You need to give the data publication and the type of resource you are describing. Now, those are the very basic metadata fields that you need to fill in order to make your data fair. I put a few web links here on the page because there's a lot more information behind the scenes on the website that researchers are invited to look at in order to make their metadata fair. I have to say, it's a real challenge to get researchers to fill in metadata descriptive templates as detailed even as this on the screen, because it isn't that, in many cases, not their current practice to do that. They'd much rather be bidding for the next project than go back and start describing their existing data in a great deal of detail. And they don't often see the benefits of filling in the metadata template to make their data fair. So the fair agenda is an important one, but it's quite a challenge at university level to get academics to agree that that is the way they're going to take their research data management practice forward. Another series of questions that the academics are going to have to answer are criteria for selection and preservation. Do you preserve everything? Raw data, semi-processed data, fully processed data? How long do you keep it for? Is it meant to be kept forever? Is it kept for 5 years, 10 years? Or can 90% of it be thrown away because it will never be needed again? So that's a decision that the academic has to make. And they make it in conjunction with their research funder, if they're a research funder, because the research funder will have requirements about how long the data should be available. So after they've made that decision, then they go on and store and curate the data that they've created. And if you were to look at who are the stakeholders in this activity, who is benefiting from or who's going to use the service, it's all these people here on the left-hand side. They're all the researchers, of course. There are the two service providers, the library and our academic computing service. There'll be research funders, because research funders have interest in laying down requirements for the data that they are paying for to be curated. And we want to interact with EOS, the European Open Science Cloud, and make our data available, or at least the metadata from the deposits in RDR available through the European portal, the EOS, in order to deliver a pan-European experience. Another set of questions that the researcher is going to have to answer, and for which they will need a hand-holding by the library and the research data team, is how to license your data. What kind of license you put on the data that you're depositing? It can't be like, shouldn't be like an open access repository where much of the many of the deposits don't have any kind of license attached to them. So the default license is CC0, which is the most liberal of the Creative Commons licenses. And you have to explain to the researcher what that means in practice, that their data will be available for sharing and reuse and repurposing by another researcher who would be able to download the data from RDR and reuse it in their own repository or in their own workspace. Of course, the data will need to be cited appropriately so that the original author is known and the original source is known, so it needs to be identifiable. The CC0 really is a very generous license in terms of the levels of reuse that you can make from the data that you're looking at. That is open data and is a new concept for many researchers. And so the final kind of case study or issue I'm going to look at here is how much does all this cost? I showed in earlier diagrams how the RDR, the repository, is a collaboration between the library and information services. And so those are the two departments that have had to bid for money from the Central University to fund this activity. The capital costs, the one-off costs for establishing the repository have come in, the project costs, and they have come in at £500,000 to establish a university-wide research data curation service. That has covered the project management, the hardware and the software. Since we bought, we use Figshare, which is a third-party research data management solution, who came top in a competitive tendering exercise that we undertook. But there are also some current staff already in post, like myself, who have supported the project, which don't appear in that £500,000 price tag. So I chaired all the project boards for the project and went to all the tendering demonstrations by the companies that were tendering for the contract to deliver the repository. So it's £500,000 capital plus some ongoing costs, which will be met by the budget because the staff are already in post. And then to run it as a service, we will need to increase the staffing levels in both the library and in information systems. So we have 2 full-time staff in the library who are our research data team. We'll need to double that to 4, so I'll need to find money or bid for money for 2 more staff from the UCL budget round to give us the critical mass of staff that we need. And we will need 1 more member of staff in, technical member of staff in information services in order to manage the technical infrastructure that the RDR is built on. So in the presentation, I presented a number of challenges for the university in establishing this repository, levels of engagement with the researcher, and new things that the researcher has to do in order to comply with their funder requirements or to embrace open science principles. Costs are a major constraint. It's not cheap to run a research data repository. So in order to make it more palatable, you have to introduce incentives. You have to give reasons why researchers an academic should walk down this path. And what we've done in UCL is to change our promotions criteria to reward open science practices. Now, this is Bernard Wantier. He was rector of the University of Liège in Belgium, and he has just chaired a working group of the European Commission looking at the reward piece in open science, and they've just published their report, and here is the URL to their report on evaluating research careers in an open science context. And now, in the current system, reward and promotion is nearly always undertaken on the basis of publications only, on the articles and the books that you have published and created. Here in the matrix that Bernard has established, he's identified 6 general themes and 23 criteria which support open science and which he is suggesting should be the criteria for awarding researchers going forward. And you'll see there in theme number 1, research output, that data sets do form one of the 23 criteria that Bernard's identified for delivering open science and so rewarding open science. This is a report, it's very new. It was published earlier this year. There is not one example yet of a university anywhere in the world that has introduced all these 23 criteria to change their appointments and promotion system. So this is work to be done to deliver open science and open data to reward people appropriately by adopting reward patterns that look like this. We have done something here in my university. We have changed our appointments, we have changed our promotion criteria. So in our academic promotions framework, I've given the URL for this document here on this slide, we have made openness a criterion for rewarding researchers by them being able to be promoted through the grades from grade 7 right through to grade 10, which is the professorial grade. Open science and open dissemination are incentives and can be used in the case that you make for promotion here in UCL. And we are one of the first universities anywhere in Europe to adopt this schema for promotion in the university. So that's one of the 23 criteria that Bernard has identified. We now need to work on the other 22 in order to deliver the appropriate and proper open science framework. So what's my conclusion when we look at the research data activity here in UCL? Research data is the new currency in research outputs. It supplements the current fixation with publications by introducing new forms of output as being valid research outputs, which should be rewarded in the same way as publications are. The establishment of our new repository, the Research Data Repository, does fulfill our ambitions for openness and our commitment to open science as expressed in our institutional research strategy. There are challenges. Engagement with researchers is a challenge because they don't always see why they need to change the way they work. And costs are a challenge because it is an expensive operation to deliver open science and the correct infrastructure. But it has enabled us, the establishment of the Research Data Repository has enabled us to exert a leadership role in open science in Europe, which is our ambition. In UCL, it isn't good to come second. You always have to be the first. You always have to be the leader, which is why we've made this a priority in our open science activity. Well, so that is the end of my presentation. Thank you to everybody who has been listening. I'm very happy to hear or answer any questions people might have about things that I've said.
Thank you very much, Paul, for your interesting presentation. Yeah, and one of the questions I have, Paul, is you talked about, and this is a question that also came from one of the participants, about the digital preservation. So you said that the decision on what part of the data set, what data are preserved, is basically left to the research, to the academic, right?
Yes, that's correct.
How do you balance the different perspectives that the academics may have and the different perspectives of the different stakeholders? I mean, because in this, as you already mentioned, and I think this was a clear message from your presentation, in data research, there's a lot of stakeholders involved. Now, these stakeholders, library, academics, for example, just to name two, have very different perspectives on digital preservation. How do you reconcile those different perspectives?
Well, that's an interesting question, and of course there are different perspectives on the question of preservation. If you were a records manager, say, in a conventional paper records office, and we have a records office here in UCL, it's part of the library. You would, if you inherited a paper administrative archive, you would cheerfully throw away 90% of it when you were weeding it, and just keep 10% and say that's the preservation corpus, just 10% of the original. The culture in libraries is quite the reverse. The culture in libraries is to keep everything rather than throw it away. So a librarian would probably keep 90% and then he'd throw away 10%.
Yeah, exactly.
So the decision about what to keep or what to preserve is a dialogue between the research data team in the library, the researcher, and the requirements of the research funder. That's basically how it works. And that's an ongoing, that's why you need, in your data management plan, you should be deciding right at the start of the research activity what it is you're going to do with the outputs, what sort of outputs there will be, how many outputs, what the size of the outputs, and then decide at the start what is worth preserving, what is important to preserve, and what could be disposed of. In the UCL survey that I demonstrated, I read a couple of results from at the start of the presentation, where the survey we did in 2015, you'll see that half the academic body who responded didn't start thinking about data management until well into the research project, and in some cases, not at all. That can't work in an open science environment because you're making decisions too late. You've got to make all the decisions and embody them in the data management plan and balance the different needs of the different stakeholders. And the data management plan should be the determining factor which tells you what you're going to keep and what you're going to throw away. As an absolute minimum, any data that's used to justify arguments and conclusions in a publication should be kept. That would be the absolute minimum. So that would be the starting point of the discussion between the library research data team and the research team who are producing the data. And you'd go on from there to agree whether you keep the process data or some of the raw data or none of the raw data and take it from there. Remember that in some of the subject areas we're talking about, they're producing enormous quantities of data. I mean, astronomers are producing fantastic amounts of data every day you couldn't possibly keep everything because there isn't enough storage space. You'd fill all your storage space within days if you were keeping absolutely everything, because they produce so much data. And it's very visual and very graphical. So that's taking up a large amount of storage space. So that's why the data management plan has to be really clear right at the start what it is you're going to keep and what you can't keep.
All right. Thank you. This dialogue, Paul, I think is really interesting what you mentioned there, and this what I understand there is that this is a process, right? So I mean, the different stakeholders that you mentioned, the researcher, the funder, the research data officers of the library, I mean, they are all growing in this role and gaining experience there. So this is because when we talk about changing culture, and this is something that you emphasize a lot in your presentation, when you change culture, I mean, that can only happen when, let's say, all these stakeholders are going in the same direction and are basically aware that a cultural change is needed, right?
Yeah. Yeah, the model comes from our open access team that look after publications and UCL Discovery, which is our open access repository for publications. Research funders have very strict requirements about open access publication for publications. And we have quite a big team here in the library who deal with researchers on an individual basis to talk them through the various steps that they have to go through in order to make their publications open access and so to comply with funder requirements. And that team has made open access really popular across the university because it's seen as a service that academics can use. It isn't just a series of requirements that are being imposed on them by a third party, and they're being left to fend for themselves. The point of having the OA team there is that we do handhold and we do answer individual inquiries, and that's a dialogue, and there might be a dozen interactions between the open access team for a publication and the individual researcher before the publication is made open access, either as a gold OA output in a hybrid journal or a pure born OA journal, or is put as a green output in UCL Discovery, which is our repository. So what we've done is take that model, which we know is successful and works, and are applying it to the research data piece as well by building this team of research data specialists who can interact with research groups and the PI, the principal investigators, and have this discussion and dialogue with them. And we often support research groups in writing their research data management plans. And sometimes those research data management plans are sent to us for verification before they're signed off by the research group. And that's, as I say, where you answer all the difficult questions about amounts of data that's being produced, the format in which it's going to be stored, is it going to be stored, how long is it going to be stored for? It is a dialogue, it's an ongoing process. The library has become part of the research process. And that's made the library very popular and reinvented what the role of the library is in the research process, because you're not just storing stuff on the shelf, you're actually working alongside the researchers to help them deliver what it is they want to do.
All right. Another question that came from one of our participants
Sure.
is, I mean, these questions are coming in through chat.
Very good.
So you mentioned the open access, which is another important change of culture. What are the main similarities and the main differences between this open access change and this open data change?
Okay. Well, one of the differences is cost. It's much cheaper and easier to run an open access repository than it is to establish a research data service with the infrastructure that's required to store and curate the data. Why? Well, partly because the size of the data sets that you're creating is much, much larger than the equivalent of publication. So the size, storage and size are factors. Research data management isn't so well established across all academic disciplines. And that's true of quite a number of research disciplines where there is no established best practice in how to manage research data in that particular area. So you're starting from a very low starting point in many cases in educating and training and working with researchers to get them to see their research data as just as important as the publications. They all know about publications because it's how they traditionally how they've got promoted and how they've got pay increases. So they understand about publications, but there's a much more development that needs to be done in terms of making people aware about the requirements of good data management, and then getting researchers to embrace their data principles for their metadata or open data for their data outputs. That isn't a one-off event, that is a dialogue. And you need to show the benefits for the researcher of them doing that. I think it's a bigger ask altogether in the research data space. Not impossible, but it is a big ask compared to publications which are, as I say, smaller, much better established in the research landscape and are therefore easier to deal with.
Okay, and in terms of staff, when you compare the open access team with the open data team, what differences and similarities do you see there in terms of profiles, size of the team, and other characteristics?
Well, the open access team has been in place for, well, how many years? 7 or 8 years, I guess. And we've managed to grow the team because there is a funder requirement for 100% open access for our research outputs as part of our national evaluation exercise, the Research Evaluation Framework, the REF. And that has been a major driver for open access to publications because unless you can show that all your research outputs are publications are open access, you don't get money from the funder. So the size of the team in the open access publications team is about 12 people. It's quite big. I'm saying here for the RDR because we're starting from scratch. We only launched the repository in June. We have 2 members of staff. I've had to find money from my own budget for 2 members of staff to launch the service. So they are the research data support team at the moment. I'm hoping to build that up with another 2 in the next 3-year budget cycle. That isn't enough, but in universities where there are 101 requirements, you have to build up your team gradually. You can't do it all at once. In terms of skills and knowledge, well, there's a common understanding of open access and open science across the publications team and the research data team. But I would say the research data team does have more specialized knowledge on research data issues that you wouldn't necessarily expect to find in the publications team because they're not dealing with research data. So the licensing discussion, for example, is a different one for the publications team, the default license for an OA output in a gold OA journal or a hybrid journal would be CC BY, or if you want to be more restrictive, CC BY NC or ND. And you have to have that conversation with the academic about what NC means, what ND means, and what CC BY means. In the data space, you're talking about much more liberal licenses. You want to embrace open data. So there would be open software licenses that the team would be asked to talk to the researcher about if their output is software, or CC0 if it's research data. And that wouldn't be a discussion you'd necessarily expect the publications team to have a great deal of experience in. I mean, all these things can be learned, but it's specialisms. There's a common layer of understanding about open science, which is common to both teams. But then when you dig down and start looking at the detail, it gets more specialised, and then there are special skills and special knowledge that each team would have that the other might not necessarily be aware of.
All right, thank you. In terms of coverage of the data, have you experience with retroactive collecting data from the past, valuable data from the past, or are you only focusing on the new data that are currently being produced and will be produced in the future?
Yes, that's a good question. Well, we only launched in June, so we are very young. So we're starting with new data that's being produced now, because that was felt to be the single most pressing issue, the starting point. What we will do going forward, a piece of development work that's underway at the moment, is to look at the separate, I said there was a separate storage service that was curating, or not curating, was storing data that is being developed through project funding. That's a research data storage service. That's not a curated service, it's not the RDR. The data there was meant to last only as long as you get project funding, and was just a workspace where you could work and share your data. It was not meant as a preservation facility or a curation facility to make data available after the end of the project funding. A piece of work that's underway is to look at all the automatic transfer of data from the storage service, the project storage service, to the RDR, to the curation service, automatically or semi-automatically, so that older research that's represented in the storage service, once that project funding comes to an end, you decide, or you have decided already, you should have, what data you're going to preserve, and then you can transfer that using the tools that we're going to develop automatically into the curation service, because it's supporting published outputs or it's data which would be otherwise difficult to reproduce, and so would be useful for making available for sharing. But the starting point for the service, as I said, was new data rather than historic data.
In terms of metadata, so you said that academic researchers don't necessarily see the benefits of metadata, even if it's a very, I mean, for us, a very basic scheme of metadata. It gives to an academic, the impression that it's generating extra work. What's your experience now? How do you see a change there in terms of culture, that academics increasingly understand that this is absolutely needed to make open data possible?
That's a difficult question. I think for established academics who've developed their careers not using open practices or fair data, I think the default question they would ask is, well, I still don't understand why I should bother. So for established researchers, I think it's a bigger ask. Some subject areas are completely wedded to open data, and there the culture has already changed. So high energy physics, astronomy, they would see open as the default. That culture has changed. But in other areas, in many areas of medicine, in my area, in history, there's still a discussion to be had about the value of making data open, or even sharing data at all in some cases. The way we tackle that is we've tended to concentrate on early career researchers, on doctoral students doing PhDs, and we have open science training courses as part of the doctoral school training program, and there we do try to embed at an early stage in their research career the values of openness and fairness when it comes to research data, so that this generation of research students will be the next generation of full-time academics in universities and in research institutions. And there you manage to talk to them early on in their career about the benefits of open ways of doing things. And there the conversation's easier, because many young people do see, young in the sense of being early in their research careers, do see the advantages of following open approaches and want to be open scientists and open researchers, because they see that as best practice in undertaking research activity. But it isn't, the culture, the academic culture, will take a generation to change. It isn't a quick win. I mean, when Nehru said culture needs to change, we said that knowing that it would take a generation, 25, 30 years of a lifespan of a researcher to move to where we want to be, and it wasn't going to be a quick win.
Right, thank you. A short or two short questions. You recommended DataCite as a metadata scheme.
Yes.
There are other schemes,
yes, there are.
such as the OpenAIR, for example, which is a prominent one in Europe, and I think also here in Latin America and the Caribbean. OpenAIR is rather well known.
Sure.
So why did you decide to go for DataCite? And a similar question I have on Figshare. Why did you decide to go for Figshare?
Okay. Well, as I said, on the metadata piece, there are many different schema. Some are discipline specific, and we do recommend academics to use them if they want to. Some funders recommend schemas, so you should follow those. You're being funded by them. DataCite, of all the other schemes, the more generic schemes, DataCite was the one that our research data team chose, because that has greater visibility in the UK than some of the OpenAIR options. I'm not saying it's DataCite is a better system, it's just better known. But it would be perfectly acceptable to use another university or another continent to use another metadata schema if they wanted to. We simply chose DataCite because it was probably the most visible generic scheme that is used in the UK. Why did we choose Figshare? Well, we had a public tender, and we set criteria in the tender, and we had all the bidders come in to demonstrate to us, and we had teams of library staff and academics, mainly library staff actually, testing the systems that were being offered as part of the tender process, to see which was most user-friendly, which was most reliable, whether they could break the system in any way by overloading it with data, or just testing it to its hilt. And then we marked, as you would in any tender, we marked all the tenderers who are making offers to us, and Fixture came out top. It was a very tight race, as you'd expect. There are a number of very good providers who could have made an offering to us that we would have been very happy with. But Fixture, on balance, was the one that we chose because they came top in the tendering process. So we awarded them the contract. And I'm happy to say that our experience since then, since we went live, has been very positive, and they are very responsive, and the system performs well. Now it's being used in anger by researchers depositing data, and downloads being made by users of the data that's been made open in that way. So we're very happy with the solution.
Okay, and then one final question, Paul, about Plan S.
Oh yeah.
Everybody's talking about Plan S in Europe, here also in Latin America. What's your expectation from Plan S? What do you think is going to happen, and what do you think is going to what kind of influence it's going to have?
Okay, well, Plan S doesn't really say a lot about data. In fact, it doesn't say anything about research data. So I think that was a missed opportunity to implement an open approach to open science, which was more embracing than the current version of Plan S, which deals entirely with publications. And from what I've been saying in the last hour, you might say, well, that's a rather old-fashioned way of evaluating research, because it's just looking at one output. So in that sense, it was a missed opportunity not to bring open source software, research data, other outputs into the discussion. Plan S is extremely challenging. It is not universally liked by academics, who see it as an intrusion into well-established publishing practices. I can say here in UCL, everybody agrees with the ambitions of Plan S, that we should have 100% immediate open access for all publications. We had a town hall meeting here in UCL with 120 academics in the room, and everybody agreed that open access was the way forward. What they didn't necessarily agree with were some of the mechanisms that were being used by Plan S in order to deliver that solution. Arts and humanities were very unhappy. Many scientists were unhappy at being told where they could publish or how they could publish. And the time frame between publishing the plan and implementing it was very short. Originally, all these changes had to be made by 2020, and there wasn't enough. I think there was a feeling there wasn't enough academic consultation, and the academic voice was not being heard. LERU and other bodies have had discussions with coalitionists who are promoting the plan. The plan has changed as a result of those discussions, sometimes very favourably. So all the requirements for green open access repositories have been relaxed. They're now simply recommendations rather than requirements, which is good because there was scarcely any repository anywhere in the world that would have met the requirements in the original version of Plan S, and that would have been disastrous for the development of green OA. So coalitionists are listening, and there is ongoing dialogue, and LERU is continuing to have discussions with them. We have another meeting with them in December in Strasbourg to carry on that dialogue, to try and find common ground. I think the biggest challenge to Plan S, and my final point, and I'll be quiet, and Plan S is built around there being transformative deals, so that all the publishers who are being contacted have to develop business models which will deliver 100% read and publish with immediate open access. Our experience of transformative deals is that they inevitably increase your costs, because publishers can't see that you can only take the subscription cost and make that the basis for the negotiation. So publishers are asking for too much money for transformative deals, and universities don't have that money. There isn't a bottomless pit of money that will deliver open access at any price. So actually the biggest threat to Plan S is not being able to deliver transformative deals, because the costs which the publishers are asking for these read and publish deals are greater than the universities can afford to pay. And that's why you get developments like the state of California not dealing with a particular publisher, or Project Deal in Germany not dealing with a particular publisher, because there isn't a common ground between the different stakeholders on what is a reasonable price. Now that discussion should really have happened before Plan S was published. It's a bit late in the day to say these costs are going to be greater than you're paying at the moment for subscriptions, and have a very short time frame in which to deliver the change. So I'm really not sure that all the publishers can transfer to transformative deals by 2021 in the way that Plan S is requiring. We'll have to see, but I think that my advice to UCL has been that that is the biggest threat to implementing Plan S, that it's simply unaffordable and cannot be delivered in the time frame. It's 2021 now, can't be delivered in the time frame that Plan S has set in its revised plan. But we'll have to see. That's just my view.
All right. Thank you very much, Paul, for sharing your view on Plan S. That's really really interesting. All right. So with this, we close our webinar of today. Thank you very much again, Paul, for your time.
No, absolute pleasure.
And for sharing your experience of this great data repository in University College in London with all of us. Thank you.
My pleasure.
All the people who participated virtually in this webinar. I would like to invite you to our next webinar, that is going to be on the 26th of September, and which will be presented by Jimena del Rio Riande, who's going to talk about digital humanities and open science. So 26th of September, and we're obviously looking forward to your presentation, to your participation. And obviously I would like to thank Claudia, Marlene, and the whole team here of the Hernán Santa Cruz Library of ECLAC in Santiago de Chile for the organization of this webinar as every month. Thank you, Paul. Thank you all, and we'll be in touch soon then.
Okay, thank you, Walter. And it's been a great pleasure to participate with colleagues in Latin America and the Caribbean today. I'm sorry my Spanish isn't up to speaking in Spanish. My reading Spanish is not too bad. My spoken Spanish is dreadful. It's much better in English, I'm afraid. But thank you for your patience in listening to me talk in English for an hour.
No, thank you, Paul. It was a great presentation. Thank you. All right. Bye. Thank you.
Goodbye. Thank you.